A very good evening to everyone. I'm Anuga Hettiarachchi, and I'll be moderating this event for the evening. I warmly welcome you all to this introduction and awareness session of the IEEE 18.0. So let me first start by telling you what IEEE Extreme is. IEEE Extreme is a 24-hour algorithmic coding competition organized by IEEE, where teams from all around the world compete to solve a set of programming problems. First, let's watch a video that explains what IEEE Extreme is all about. Okay, we will proceed. And before that, I'll let you know that this will be an interactive session. So questions will be asked throughout the presentations, and it would be great if everyone here could answer and make it a very productive discussion. So if you have any questions, and please be kind enough to save them for our Q&A session, which will be conducting closer to the end of our session. So now let's look at what exactly IEEE Extreme is, why we should participate, and how we can participate in this year's IEEE Extreme. So to get in-depth answers for those questions, I warmly welcome our guest speakers, Mr. Athulya Ratnayake, Mr. Praveen Sumanasekara, and Mr. Buddhi Wijenayake. These three talented students, currently in their third year of studying electrical and electronic engineering at the Faculty of Engineering, secured the national champions at IEEE Extreme 7.0, which was held last year, placing them 65th in the international rankings. We are eagerly looking forward to the wisdom and knowledge they will share with us today. So first, let's welcome Mr. Athulya Ratnayake.
Okay, thank you, Anuka. So, can you hear me? And I think that I should turn on my camera. So, can you give me a quick feedback that if you can see me and hear me? Anyway,
We can see and hear you very well.
Okay, so I will share my screen. I have to share my entire screen. Okay. Now, can you see my screen?
Yes.
Okay. Now, if there is any problem with my audio or video or my presentation, please let me know through messages. Okay. Now, today what we are going to do is we are going to talk with you about IEEE Extreme. Not only about IEEE Extreme, but certain topics will touch the other programming competitions as well. So before moving into that, I will give you a quick breakdown about the topics that we are going to discuss today. So first we will introduce you what IEEE Extreme is and the background stories about that, the background about that. Then we will move on to the preparation. And this preparation part is not dedicated for IEEE Extreme. So if you are going to do computer programming, you need to do the preparation like this. So after that, we will move on to a quick demonstration about the platform where the IEEE Extreme is conducted. So we will give you a comprehensive demonstration about that. Then after that, we will share you some details about some kind of sort of like personal tips that we have followed when we were doing computer programming. So after that, we will move on to the Q&A session. So that is the breakdown of topics that we are going to follow today. So I'm Athulya Ratnayake. As Anuka correctly mentioned, we are team INSOMNIACS. So I'm Athulya Ratnayake. I have my colleagues Praveen Sumanasekara and Buddhi Wijenayake with me today. So let's start by talking about what is IEEE-Extreme. Now, before moving on to specifically about IEEE-Extreme, we will talk about competitive programming. So before that, can you give me a quick feedback to not to get an idea about the audience? Can you please drop me a message if you have participated in any kind of competitive programming competition before? Or you can raise your hands. If you have participated in any kind of competitive programming competition before, please raise your hand. Now, there are some people that I directly know that they have participated, but they are not raising their hands. Why is that? Can you guys hear me? Okay. Okay. One from the organizing committee. Well, I'm so concerned about the participants, the people that I don't know their names. Okay, now, okay. So can you raise your hands if you have not participated in any competitive programming competitions? If you have not, please raise your hands. Okay. Thank you, Buddhi. So Buddhi is raising his hand. Thank you. So now I hope that I asked a binary question, right? Binary question means it has two possible answers, either yes or no. So there cannot be people who are not raising their hands for either of the questions. So it means that you have not get the message that Anuka shared with you before the discussion. This is going to be an interactive session. Now, the benefit of having an interactive session is now for you, you can actively participate with the event, actively connect with the presenters. And for us, we can make sure that you are not sleeping and you are always with us. Okay, Buddhi raised his hand for the previous question. Okay, okay. Now, in competitive programming, now since majority of the audience is not aware about the competitive programming, now they have not participated in such an event, I will give you a quick understanding about what competitive programming is. Now, in competitive programming, what we are doing is now there are some people, some bunch of guys called the organizers, and they will set some problems for you. Now, these are some real world problems. The problem comes as a story. So at the end of the story, they are asking you to do something to solve some problem. So you use your programming skills to solve that. Now, you can use any programming language in the sense that you can't use those non-popular programming languages, but all the popular programming languages like Python, C++, Java, C, and all the non-programming languages are out there. So you can use any programming languages to solve those problems. So you are getting an algorithmic approach. So it does not imply that you always need to use algorithms and data structures and all. You can create your own answer or your own algorithm or specific data structure which is dedicated to solve a certain problem. It is totally okay. You can make an algorithm or you can make a data structure. It's totally all right. But the majority of the problems you can solve using traditional algorithms and data structures. So make sure that you get familiarized with this stuff when you are going to any kind of programming competition, and we will be helping you by teaching you or by letting you know how to do that. So that is competitive programming. So in competitive programming, we have competitive programming competitions. Now that is a sport. Now when it comes to sports, we know that there are two kinds of sports. The first kind is where you should use your physical strength, and the second one is where you should use your mental strength. Now, competitive programming focuses on latter. It means that competitive programming is a mental sport. So don't try to use your physical strength when you're doing competitive programming. Then you will break some chairs or tables when you get wrong answers. So now talking about wrong answers, now don't be now. I will ask you questions. Now those questions are not rocket science. Very easy questions like the one I asked before. So please answer because I am asking those questions to get an idea about the audience because I'm not going to punish you if you haven't competed in competitive programming competition. I want to know that to get an idea about the audience. Then I can decide that from what level I should start. Okay, so please do answer, because in competitive programming, as I always say, in competitive programming, always you get wrong answers. It's a very limited number of times you get the correct answer. So don't be afraid of wrong answers. Please do answer. Okay, now when we focus on IEEE Extreme is one of the largest competitive programming competitions in the world. Now, there is another competitive programming competition called ICPC, I guess, that is the largest one, but IEEE Extreme is one of the largest competitive programming competitions in the world as well. So now in competitive programming competitions, there is a duration for the competition. So there are 6-hour competitive programming competitions, 12-hour competitive programming competitions, and IEEE Extreme is a 24-hour competitive programming competition. So as I could learn this time, IEEE Extreme 18.0 start at 5:30 on the 26th of October. It means that it will be finished on 5:30 at 27th of October. So you have to program for an entire day. So don't get afraid that when I'm telling this stuff, because believe me, this is very fun, because you are not doing it alone. You have 2 team members, 2 of your colleagues doing the same thing with you. So don't be afraid. This is very interesting. So IEEE Extreme is 24-hour programming competition, which is conducted in CS Academy. So in this case also, you will get a bunch of competitive programming problems. So you can collaborate with your team members and solve those problems. And while solving the problems, you can earn marks and secure a position globally and in your country. So now I have mentioned that IEEE Extreme is one of the largest competitions in the world. So you can see these 2 dot points below in the bottom of the screen. So in IEEE Extreme 17.0, I am not very much confident about the numbers, because I'm not sure that it was more than 17,000 or so, but to be in the safe zone, we will say that the number of participants exceeded the mark of 15,000. So 15,000 is a very big number, right? 15,000 guys, more than 15,000. So yeah. So when we talk about IEEE Extreme 16.0, it was about more than 14,000. Now, when you see these figures, you can see that this is, as I mentioned, this is one of the largest competitions, and this is continuously growing. And if you take the details about the past competitions like IEEE Extreme 15.0, 14.0, you will see this is growing. So that is evident that this is a very good opportunity for you all to showcase your talents and to get recognized. So when talking about recognition, we will talk about it in the next slide. So I just this slide. I think there is okay. Okay, now let's talk about the benefits of participation. Now, the main benefit that you can gain from participating in IEEE Extreme is recognition. So to emphasize that point, I will give you a story. So the story is about a past student from our faculty, the Faculty of Engineering. So when he went to higher studies, when he applied for higher studies for a certain university, I'm not going to tell the name of the university, because then you can find his name. It is totally all right to find his name, but considering his privacy, I will not give you the name of the university. But it is not an ordinary university. It is one of the best ranked universities in the world. So when he sent his CV and academic transcript to that university, his supervisor was an ambassador of IEEE Extreme. So luckily, he has competed in, I think, 2 versions of IEEE Extreme. And believe me, in the interview, the IEEE Extreme was the starting point, and he got that opportunity. This is not an ordinary university. This is a well-known university, a highest ranked university in the world. So if you don't believe me, you can go and ask from some lecturer or some senior, and they will tell you about with the details. So that is about the recognition, and not only in higher studies, when you are applying for jobs, then participate in IEEE Extreme. I'm not talking about winning. Participate in IEEE Extreme would give you a lot of advantage over your competitors. So I will give you another story. This is when we competed in the last year. And after the competition, we had the awarding ceremony in the faculty. So the sponsor for the awarding ceremony was Zone 24/7. So if you are not aware about Zone 24/7, I don't think that T21s are aware about Zone 24/7. But if you don't know, you can search it in Google. So Zone 24/7 is well-reputed company in Sri Lanka. So the ambassador, the person came from Zone 24/7, gave us an open invitation. This is an open invitation, not only for the winners, all the participants. He said that when you are doing your internship, or when you are finished with your degree, and when you are applying for industry, please apply for Zone 24/7. So he invited us to send our CVs to his company. So it is evident to for my point. My point is, you can gain a lot of recognition by just competing in IEEE, not winning, by competing. So, and this point 2 and point 3 goes hand in hand together to gain confidence and learn new things. Now, I told that we are taking algorithmic approaches to solve problems. So it implies that to solve problems, you need to know about algorithms and data structures. Now, unless you are doing, you're going to do computer engineering specialization, you are not going to touch these stuff. But when you go for job interviews or any kind of interviews, they will check your knowledge about these data structures and algorithms by using certain tricks, by giving you a question to answer, IQ type question to answer, to give you a problem to solve, or something like that. They will check your knowledge about these algorithms and data structures in every interview in engineering industry. So if you don't do computer engineering, you're not going to touch this stuff. So imagine that one of your colleagues are fluent in these areas, but you are not, then you will be rejected from the interview. So you can make this an opportunity to learn about this stuff. And once you learn, you can use them. By using, you can gain confidence. It is beneficial for your academics as well. So this will give you a good recognition in the industry, in higher studies. So even within the university, you will be recognized, and then you can take this opportunity to learn new things that you are not going to encounter in your undergraduate studies. And even if you are doing computer engineering, learning these things at this level will help you to do that course in, I guess, data structures and algorithms course is in third year. If I'm wrong, please, computer engineering student, please correct me. You can send a message to the chat in which semester you are having the data structures and algorithms course. I think it's in third year. So you can take this opportunity to learn these things even before you are starting that course. Okay, then let's move on to the eligibility. Eligibility means what makes you qualified to be a part of IEEE-Extreme. So to be a part of IEEE-Extreme or to compete in IEEE-Extreme, you need to have the IEEE membership. All the participants in the team, all the participants of the competition should have the IEEE membership. So it will cost you some money. Last time it was $7 because I think we had a discount or something. It's normally $14. So $14 per year. So you have to renew it after every year. So now this don't allow this membership fee to be a barrier to your participation in IEEE-Extreme. If you can't afford it and you are very interested about this stuff, you can go and ask from responsible people, then they will help you. So please don't disregard that membership fee if you are not, if you can't afford it. If you can afford it, being an IEEE member will be beneficial for you as well. So take that membership. And then the number of people in the team, you can have a maximum of 3 people for the team. So now this sentence here, the maximum 3 members per team, that sentence here will imply some important things. So now in the rules in IEEE website, they have mentioned that you can't take any information about the problems, so get any help from the outsiders. Outsiders means the meaning of that sentence is the only people that you can discuss about the problem is the 3 members of your team. That's all. You can't take information or take help from any other groups. So take help from someone is not participating in IEEE, that is totally prohibited. So if you get caught by doing that, you will be immediately get disqualified. So it has happened in the last competition as well, because at the end of the competition, our global rank was 69. But when the results came, we were 65. So some teams might have got disqualified to since they have broke the rules. So Anna, the proctors. The proctors are the people that who are regulating a team, a certain team. Every team should have a proctor. Proctor cannot be a student, a graduate student or undergraduate student. So he should have a higher membership grade than a graduate student. So it means that the people that we can reach to be our proctor are our lecturers in our faculty. So there are lecturers who have been proctors in the last competition. So you can ask from them in the faculty, and they will not decline you, and they will help you. So the job of the proctor is they should make sure that the team does not break the rules. That is the first thing that the proctor should do. So breaking rules means he should check whether you are getting information from any other person or any other team. Or now this is not directly given in the rules, but if you try to take a code from the internet and directly apply that code into your answer, that is not going to help you in that is not going to help you. So if you want to take information from the internet, you take it, but do some changes. So then we can make sure that you are not you are still in the safe zone. So the proctors will regulate you to obey to the rules. And then now I have mentioned that this is a 24-hour programming competition. So you can't code for 24 hours straight, right? So you should have some rest. We are going to talk about those stuff in the fourth part of this session. So for now, you should take rest and you should take your nutrition, and proctors will check on those stuff as well. And if the proctor is not checking about those stuff, please do, because taking a good rest and taking a good nutrition will boost up your brain power, and it will be advantageous for you. Now, when talking about prices, let's talk about prices. And to do that, we will go to the IEEE page. Now, can anyone give me a feedback that you can see my browser, the IEEEXtreme.org webpage? Can you quickly send me a message? I'm expecting a message from a participant, not one from the organizing committee. Participant. Can you please, before I mention a name, please? No. Okay. Anyone from the organizing committee, please? Can you see my screen? Okay. Okay. Thank you. One participant has also responded. That is very interesting. And thank you. So this is the code that I put into my presentation. So here you can see about IEEE stats. See, the number of participants has increased. So now this is the prize for the first place. The team who is getting the first place cover a trip to the IEEE conference of your choice anywhere in the world. So they will take care about the money and all stuff. Then we can go a trip to anywhere in the world where an IEEE conference is held. And for the second place, they are giving us 400 US dollars. So you can convert it to currency in Sri Lanka, Sri Lankan rupees, and check whether the price that you are getting. And for the third place, it's 300 US dollars. And not only for that, for the places from 4 to 10, they will give this extreme merchandise bundle and software gifts. And for top 100, they will give this merchandise bundle and software gifts as well. So in the last time we received this bundle, and we had a pen drive and a T-shirt and a cap in this merchandise bundle. So these are about the prices. And then since the time is up, I will go quickly about this stuff now. Now I have mentioned in the last slides that we need to learn about these algorithms and data structures, and also to learn about that, we will give you references that we have used. These are 2 books, one in Python and one in C++. But don't consider the language when you are learning. You can learn from any book and do the programming in the language you prefer. So you can scan this QR code to download those 2 researchers, not research papers, 2 books. So this will direct you to a Google Drive folder. Then you can download it. But you will need your Faculty of Engineering email address. Then now, when you learn about an algorithm, it is not sufficient. You have to practice it. Now to practice it, you need some problems. Now then you can use these. You can use these websites to get the practice problems. Now the CS Academy is the website where IEEE is hosted. Therefore, I'm not going to tell about this now because Buddhi will give you a comprehensive demonstration about this site. Then this okay. Then the CSCS problem set is highly recommended because let's go and see why it is highly recommended. Now, when you come to CSCS problem set, for your case, you will have to log in. So you should create an account and log in. That is not a very big deal. Then when in CSCS problem set, you will see the problems are categorized. So now in computer programming, there are a bunch of topics that you need to cover. But since you're having 3 members for group, all of the members should not be fluent in every topic. So you can divide topics among yourselves and learn them. So when you are learning something, now say you are learning dynamic programming, then you can come to this section and solve these problems. Now these problems can be solved using dynamic programming. So when you are concentrating on dynamic programming, you can use this section. Now in CSCS problem set, this categorization is very important. Now I told you that all the members, every members in the group should not be expert in every field. Now I can demonstrate it. Now when it comes to graph algorithms, now you can see that I haven't actually attempted it because this is not my area of interest. But Praveen will say you that you have to have a basic understanding about graph algorithms. Praveen will say why we should have that understanding. So I'm not going to emphasize on that fact for now. And these range queries I have tried in the last year. So in tree algorithms, I have not even attempted, but I have a fundamental understanding about this. Now, my area in computer programming is mathematics. Now you can see majority of the problems I have tried. Now these problems I haven't tried. So I will try it for this sales competition. So now the strings I haven't touched because Buddhi is the expert in string algorithms. So like this, you can see the categorized problems. So when you try to do this, you can start with the introductory problems, start it from the beginning. So these questions are not so hard now. This is how a question looks like in CSS problem set. Depending on the platform you are using, this interface would be different. And here you can see 2 submissions made by me. And it's like that. So you can submit here. You can choose a file. For some platforms, you can copy your code and paste it in the platform and submit it. It is not a very big deal. Now, this is a submission that I have made. So this is a very easy problem, the first problem. So that is why the code is this much short. So this is how you see. Now, for the first time when you see this, getting all greens, I can't say you about that feeling, because that is the feeling that you should get as a computer programmer. Not only in the first case, now we have participated in about 5 or 6 or about 10 computer programming competitions in our lives. Still, if we get all greens, we get excited, and Praveen gets excited more than us. Sometimes he uses his physical strength as well. So, okay, now this is the CSCS problem set. Now, not only CSCS problem set, you can use HackerRank. There is a section called problem solving in HackerRank or in mathematics. So it is also categorized. So you can use HackerRank. And Project Toiler, the problems in Project Toiler is a bit harder when compared to the other platforms, but it is also, you should consider Project Toiler as well. But don't start from Project Toiler. Start from CSCH problem set by doing the introductory programs. The problems, then you can use lead code and code forces as well. Praveen will say about this code forces in his section. So I think this is what I wanted to talk about, talk with you today. So now I would like to hand the presentation over to Praveen to continue with the preparation. Over to you. Praveen, I think you are muted.
Thanks. So thanks, Athulya. Can you guys hear me and see me? I would like response from the participants, but even the organization is fine.
Is it okay if I give you the feedback?
Yeah, it's fine.
Yeah, I can see you and hear you.
Okay, all right. Okay. So I share my screen. Okay. So Athulya gave you an introduction. Okay. So Athulya mentioned about prices. So like this is one. IEEE Extreme. So we have the cap and the pen as well, but I don't have them with me now. Anyway, so Athulya talked about giving an introduction to the IEEE Extreme competition. So I will be giving a small introduction on like how to approach learning these competitive programming stuff if you want to compete in IEEE Extreme or any other competition. So like the things that I plan to cover are like strategies for learning DSA. So DSA is data structures and algorithms. What to focus on and improving problem solving skills. Like I won't be giving like okay if 50 is this how to do binary search things like that. So I'll be giving you tips on how to learn any algorithm or a data structure. So basically, I'm giving you the fish hook. It's your responsibility to go and fish. So with that sort of mindset, we'll continue. So like this is probably like a very obvious kind of advice, but like people tend to miss this. Like you really need to do practice problems. And I can't really emphasize this enough. So that is why Atulya gave those list of resources and more. Like we had like 2 books that covered theory, but there were a lot more resources where you had to go and solve problems. So because like in competitive program, it's not so much about the algorithm and the data structure, but how you use them. So you can't really learn them with like textbooks. So the books we have like do focus on that aspect, but you really need to solve problems yourself to like get an idea of how to do that. And another thing is like it's like some of the algorithms and especially techniques you can't really learn with a book because like sometimes we use really niche algorithms that you won't be covered in a book or even a like even a, like a university course because they are not like often used in like the industry and stuff, but they come in really handy when solving like these tricky problem-based stuff. Yeah. So Atul has also given a link for the references. Okay. And now, so do practice problems. So kind of obvious advice, but I'm telling this to begin with, but because like this is probably the most important advice. So when doing problems, like you need to know when to give up. Okay, so what do I mean by that? When knowing when to give up. So sorry, I'm in trouble. Uh, so what I mean is, like you need to look at other solutions and actually more specifically uh, for certain problems, if you can't solve them, you should look at the solution. So I hate this advice because I really don't like to look at the solution. I want to solve it myself. However, unfortunately, it's a like good advice that I have received multiple times from different sources. So it's very tempting to keep trying on a problem and refuse to look at the solution. But it's by doing questions you learn these algorithms and stuff. So if you like keep doing a question like without making any progress, you will do fewer number of questions and you will learn fewer number of things. So from my research, it is usually recommended to spend about 30 minutes on a problem. So to me, that's a very small. I actually don't like that, but it's probably the most optimal time. If you can't solve it within that minute, you should go and look at the solution and try to learn it through that. I typically spend more time on that, so maybe like an hour, or maybe I like look at the solution question in the morning, think about it during the day, and then if I can't solve it during the day, I'll look at the solution in the night. So when I say look at the solutions, I don't mean that just without even trying the question, look at the solution and okay, that's it, and copy and paste the example code given, and just say okay, I have passed all the test cases. No, I obviously don't. I don't mean to do this. I'm saying that you should take a more deliberate approach. You should study the solution carefully. And as you read you might be wondering where you get solutions. So that is why I mentioned Athulya mentioned the platform called Code Forces. So it is a platform where there are many weekly competitive programming competitions. And the good thing about it is like after the question, they provide solutions and write-ups explaining the solution. So it's a good resource to study problems and to study how to solve them. So as you read the write-up or the explanation, you might get an idea. You might get a like a light bulb moment. That's how you solve it. And then stop reading it and then go and try it again. So like it should be like a back and forth. You try it, you start reading it, you get an idea, you try it, and so that way you will learn. And so even if you don't like get an idea, once you read the solution, you should try to implement it yourself. And even if that fails, there's sometimes example code. You should try to read through the example code and understand why they have done each and every step. So you should ask questions from yourself, like why have they taken this step? So, oh, why didn't I think of that? What experience am I lacking? Or maybe I don't know this data structure. What if I use this instead? So I don't know whether you are familiar with this, but maybe what if I used a ordered set instead of a priority queue? Things like that. Can I adjust the algorithm to make it more efficient? So, and you should try to solve it in different ways. So taking that solution as an inspiration. So I find that most competitive programmers tend to stay in like one of the two extremes, never looking at the solutions. So most people are like this. So uh, like I am like this, and a lot of people don't like looking at the solutions because they like to solve it themselves. there are few people who always look at the solutions without trying them. So what I'm saying is you need to take a middle ground approach. So you should stay in the middle. You should attempt it, and when you feel like maybe it's beyond you, you should, although it's hard, you should look at the solution and learn from it. And the key point is you need to learn it, not just copy and paste and just pass the hurdle of the question. So again, there are some grains of salt for that advice. I'm not saying to do this for all questions. So there may be a question that you really like, that you really want to solve. So keep a few questions like that, because like solving a question after months of thinking about it and like coming up with stuff, that is quite fun. And when you actually finally crack it, it gives you a good feeling. So it's good for your morale. So therefore, like, keep a few questions like that, because otherwise, like, you will get demotivated quite quickly if you follow this approach. And also, like, trying for a long time can also give you a lot of lessons. You might do research on different areas that otherwise you might have not done. So yeah, like, you need to keep a balance to it, but uh, like, you should consider looking at the solutions. I don't like to give this advice, but it is good advice. Unfortunately, I have benefited from this, although it's hard for me to do. So next, learn to steal from your friends. So I don't mean pickpocketing. So after you do a competitive programming session, like, ask from your friends, your colleagues, like, how did you solve this problem? You will be quite surprised at how many different ways you have of solving a question. Like, even if the final solution is different, the way they approached it, the way they formulated the question, the question, where the question and how they approached it will be quite different. So maybe in the, like, collective session, we'll talk about one where yes. So maybe in the collective session, we'll like, talk about uh, a situation where, like, we solved like, different teams had solved, although the final expression was the same, the approach they had taken was completely different. So yeah. So okay, now I've been talking about, like, how using problem solving to learn these concepts, and that is a good thing, but at a certain point you need to learn some of the theory as well. So now I'll be, like, explaining how to approach that. So this is an approach that I kind of like and don't like the advice that I said earlier, which is called the black box method, but this is very useful. So the place where I learned this first is Colin Gallen, who runs a YouTube channel that talks about competitive programming, and also, like, the kind of thing I'm doing now, like strategies for learning things, not just about explaining algorithms. So the black box method is, simply put, that in competitive program, you don't always have to, like, know how the algorithm actually works. So for example, like FFT, fast Fourier transform, like, you will learn in your, like, university how it will work, if depending on the course you take. But in competitive programming, it's more useful to know how to use it, and like, its complexity, and where not to use it, where you can get the benefits from it. And because you can do surprisingly different things with it. So there's convolution, there's multiplication, like, you can there are connections between them, but, like, when you first learn the algorithm, you won't realize what you can do with it, but you might get stuck in the implementation part. But in the competitive programming, when you're actually doing competitive program, we most of the time we don't write the algorithms then and there. We either have the algorithm pre-written, we call those snippets, so we can copy and paste, or, like, some editors have the feature, so you can just you can use a keyboard shortcut to directly paste the algorithm from a environment. So we typically don't write the algorithms then and there. We like, use a reference book or get it from the internet. But the trick is where to when and how to use it. So you should be focusing more on how to use it, where to use it, problems where it has been used. So when you are learning a DSA, so a data structure and algorithm, it's a useful thing to like compile a list of problems like that algorithm or the data structure is used, and see how it is used, and you will be surprised in how many different ways a single data structure and algorithm can be used. So another thing is you can think about different interpretations, how to think about it. It's time complexity. So like in what situations does it give you a time complexity advantage? So in what situations will it run fast simply? And complexity of different operations. So if you don't know about this complexity stuff, don't worry. The book, the references book we provided gives you an introduction on the thing. So again, like if think about data structures, you can think about what is the best data structure if you want the ability to add and remove elements and access the minimum or maximum element. So for that, you can use a priority queue. If you want to access element less than a given element, so for that, you can use a binary search tree. So things like C++ set, ordered set data structure implements this. So like actually, if you ask me to write a priority queue algorithm, or even more difficult is the binary search tree. The effective implementation of binary search tree, I won't be able to do it quickly, but I can use it very quickly. So that is the thing that you need to focus more on in competitive programming. So again, some grains of salt. I'm not saying completely ignore the thing. So what I said was to treat data structures and algorithms as a black box. So you don't really know how the internals work, but you know how to use it effectively. So you are using it as a tool, but you don't know how the tool works. There are certain situations where that information is important. So you need to change the algorithm itself to benefit you, but that is very rare. So it is better to focus on how it is used and when it is used rather than focusing on its internals initially. As you get more experience, you can dig into the internals of the algorithm. Or if you're interested. So if you're interested, it doesn't matter. But don't forget to focus on the how it is used, not just the internals. So again, it's not enough to know, you need to really internalize the knowledge. So what I mean by that is, so let's say like as you read the question, you realize that like the data can be stored in a tree-like structure. And when you just think about tree-like structure, all the things related to that must come to your mind. So you can find the least common ancestor. That should be an internal truth in your brain. So you shouldn't think, okay, if I have to do this, then I have to do the least common ancestor. No, you should immediately know, okay, if the data can be represented as a tree, then I can find the least common ancestor. If you don't know what that is, you can do the research. But my point is, you need to know what things can be done by a certain data structure or algorithms. You need to definitely know, even if you don't know the algorithm itself, you need to know what that algorithm is capable of doing. So Athulya mentioned that even though you don't, each member doesn't need to be an expert on a field, but they should have a general idea. So one of the reason is, if you read the question and see, okay, this has a tree-like structure, you can give it to the teammate that has more knowledge about trees. So that is the thing that I mean. The next thing I want to say is like, don't ignore the small algorithms, and also learn to think about them in different viewpoints. So I will take a small example, that is binary search. So if I ask a lot of you to say what binary search is, you would probably say it is a searching algorithm that finds that you can find an element in a sorted array. So that is what also, if you just Google it, that is the thing that that you get. And this is correct. And you can use this interpretation for many problems, to solve many problems. However, there are different ways of looking, right? So my favorite way of looking at this, binary search is a way to solve a problem when you have a true-false question that is easy to answer, where its truthness changes at some point. So if let's say like you have a sequence of stuff. And at a certain point, the question becomes from true to false or false to true. And there's a large search space. In these situations, binary search can be used to find the point where the truthness of the question changes. So if you don't really understand what I mean by this, don't worry. But my point is that this is not a very commonly seen interpretation of the binary search algorithm. However, for me personally, this is the interpretation that I find the most useful. So it might not be the case for you, but the only reason that I found this was because I was trying to look for different interpretations of binary search that would make it easy for me to use in algorithms. So I will give you a small example. That is the story of how we solved the hospital queue question. So I won't give you details of the question, but the story was like there was a patient called Dinidu, and he had to visit a doctor. And the question was asking like at what time Dinidu will be able to see the doctor. So complications in the yes. So Athulya remembers hospital queue. So there's another story regarding that on debugging it. We'll get to that later. But anyway, the story is that the time taken what they were asking was how long will it take for Dinidu to see the doctor. So there's a queue of patients and they're asking how long will it take for Dinidu to see the doctor. So the way that the question was set up, I won't give you the internals of it. So the way the question was set up was that it was actually difficult to find the time that a certain patient would see the doctor. However, it was very easy to find, given the time, what patient the doctor will be seeing. So the reverse question was easy to answer. So now we have an easy question, but it's not a true false question. But we can make it a true false question by saying, is the patient the doctor is seeing at time t Dinidu? So we now have a true false question. Since the doctor is seeing patients in order, then there is a linear search space and it's a large search space because the time can be like several billion or something. But now you can see that in that sense, we have the structure that is necessary for binary search. If we were using this interpretation, I don't think I would have stumbled on this solution. A search algorithm that finds the position of a target value within a sorted array. There's no target value I am searching. I am just searching when does the question answer change from true to false. And that point will be the time where Dinidu will meet the doctor. So I don't know whether you really understood the question, but hopefully you got the point that different interpretations of the same algorithm can help you in different scenarios. So try to deeply think about even the simplest algorithms. Some of the most difficult questions I have faced have been in binary search, but I guarantee you that all the competitors at the competition knew binary search, but I think we were one of the only ones who solved this question. And the the probable reason is that we had this interpretation of binary search. But if you ask any one of the competitors, they would have been able to interpret binary search. But we had this interpretation, the way of looking at the data structure, and that's the thing that changed the result. So that's why we were able to solve the question. So like whenever you learn an algorithm for the first time, you may think this can be only used in this and this. But as you like go deeper, you will realize that there's an infinite depth and infinite usefulness of a given algorithm. So you never stop learning about binary search. I'm still learning about binary search and different ways of using it. So like never say like, okay, now I know data structure, now I know graphs, now I know trees, now I know least common ancestor, now I know binary search. You never stop learning, and it's actually deep understanding of the most commonly used algorithms that help you. Clever applications of the simplest techniques will take you a long way rather than knowing like a million algorithms and million data structures. You need to have deep knowledge about the most used and the simplest data structures and algorithms. So in order to gain that, you need to practice, and more practice. So like practice makes perfect, and it is the practice that lets you internalize the knowledge so you can use it quickly in your competitive programming journey. So like that's all the advice I have. But the final thing that I want to say before we move on to Buddhi is you will never be ready. Okay. Like you will never feel ready, at least. You will never think that I know enough data structures and algorithms, especially if you have never competed before. Right. So like start now. Like, I mean, even if you know nothing about it, I encourage you to participate in IEEE and other coding competitions. And I actually have, I don't know whether you'll talk about this, but we have an anecdote of a certain someone who thought coding was stupid until he did a competitive coding program. So maybe we'll get to that. Anyway, so I encourage you to participate. So hopefully, so please, since there's only few people here, please pass on the message to others. So Athulya is asking who that is. So yeah, maybe we'll get to it. So please pass on the message to others that you know. Please like participate in IEEE. So we as a university don't have many teams, but all the teams go well. So you will be uh, so it's an opportunity to be surprised about your ability and also be gain some humility of how much you don't know. So please participate even if you have no confidence in yourself. I promise you participating in it will give some confidence or at least give some encouragement for you to learn more about this field. So again, like for to learn about learning competitive programming, I recommend this YouTube channel, Colin Gallen. So I'll share the slides later so you can go and watch that. So that's all I have in my side. So you can ask any questions if you have them now or later. But for now, thanks. I will be joining again at the end for our collective discussion. But for now, I will hand it over to Buddhi to explain what to do during the competition.
Yeah, so can Praveen confirm me that I'm audible enough?
Yeah, you can. You can.
And I think pretty much every information was there in your presentation, as well as Athulya mentioned everything. So what I'm gonna explain is how you would be participating in the competition and what you should be doing during the competition. I hope you can see my screen.
Yes, Buddhi can.
Yeah, so I will be explaining about the CS Academy. So this is where you will be, the IEEE will be hosted, and it has a kind of interesting scoring system where even though you get the answer correctly, you might not get the full marks because the score system is like 30 plus 70 times 1 minus average to the powers 2. So if the average of the score is 1, that means all the participants had got that question right, you would only get 30 marks. So that's interesting. And looking forward to what's inside CS Academy, you would see a UI like this. And actually, in the practice problems, you can see these tags, but in the competition, you won't see that. And this is how you would get the questions. And if talking about these kind of things, they have a difficulty tab as well as a stat. And for instance, some of the problems might be categorized under medium or hard, whatever, but you have to have a pretty much good idea about the stat, in the sense that some of the questions might be hard, but participants have more percentage that they have solved the question. So, but what I mean by that is you must try that out, even though it is categorized under hard difficulty level. So, going towards a question, uh, this is how you would get the question, and there are some sample input and sample outputs, and this is where you can write the code or you can upload the code as well. And in the UI here, sometimes the input is appeared here, but more of the time that you won't get the input here, so that you have to copy paste the input to here and then run it. Otherwise, if you run this one, you will get error. And to run the examples, you can run this, of course, and to submit, you can do this. So it will submit your answer and give the results. And that's it's for the CS Academy, and you will see the rank here, the global rank. To find your island rank, you have to go to the scoreboard and do that stuff. I think you are pretty much confident on using UI. And the other thing I want to mention is the other platforms that you should try out. Of course, Athulya and Praveen mentioned that Hackera and CSCS, Code Forces, and Project Developer. Going to the Project Developer, that I think Athulya missed that out. This is pretty much about the mathematics knowledge, how we use mathematics onto data science. So give it a try, and you would get some experience, and you would know how to face a mathematical problem in data science. And yeah, going back to my presentation, and you can use AI tools as many as you can to the IEEE programming competition. That's no restrictions to use that. You can directly copy paste them. But the thing is, have a clear idea about what you are doing. Sometimes these AI tools might not give the correct answer and not follow the path that the question is asking you to follow, and have a clear idea about that as well. And another thing I want to mention is sometimes the question is a little bit long. I mean, it might have few paragraphs, so you can use AI tools to sort that out, summarize that out, and have a clear idea how to approach the question. So that's up to you. You can use as many as AI tools you can. And one other thing is there's a new AI tool that Claude AI. I think you have already aware of that, but maybe try that out as well, because in the program wise, Claude AI is somewhat leading than the ChatGPT. And I think that's it for that one. And another tool I have to mention is that competitive programming helper extension on VS Code. And you can download this extension, and whenever you are facing a problem, let's say you are facing this one, and you have to download the Chrome extension as well, the competitive companion, and you would see a sign like this plus sign. And once you are in the problem, this one, you can press this. I think can't do that. Let's see. Let's take another question. Yeah, so you have to just press that one and use whatever the language you are using, and you would see the result, test cases and everything in the VS Code. So it would be easier that when you are using this is really hard to use this text as when you are coding, right? So if you are more fascinated using VS Code and stuff, that would be easier. So I thought it would be better if I mentioned that one as well. And that's it from my side. That was a short one. And thank you.
Okay. Yeah.
Yeah.
Now,
Oh.
okay. Now I think Praveen and Buddhi will join with me to share some personal thoughts about how to participate in computer programming competitions. So before proceeding with this topic, this section, I will give you a small disclaimer. The things that we are going to mention in the next few minutes are the work for us as well. Obviously, it worked for us in IEEE and all the other competitions, but we can't guarantee that it will work for you. But it worth to give it a try. So we will share some our experience that we have gained in computer programming, and Praveen and Buddhi, both of them will help me on this section. So Praveen, can you start?
Yeah. So, like again, as Athulya said, like these are personal anecdotes, personal stuff, uh, things that we think helped us, but we are not sure. The stuff we said before are somewhat well researched. So what do you start with, Athulya? Should you start with looking at the leaderboard, the controversial topic?
Right. Yeah. Okay.
So,
Praveen, you will can you
okay.
start?
So the thing is, when you like play the IEEE game, you have a live scoreboard which shows your standing in the competition. So like it's a hot topic whether you should be looking at it and be considering your place or whether you should not be considering. Now I have played with other teams as well. So there was the opinion that you should be looking at the leaderboard. But and we tried it as well. But every time we tried it, it might be just a fluke. But every time we tried it in other competitions, not in IEEE we failed miserably. Uh, so for us at least, it was not a good idea to look at the leaderboard because I don't know either we got frustrated or we tried to like think about it too much, but it didn't really work for us. So uh, the rationale for going for or at least looking at the leaderboard is that you can see what other competitors are actually solving, and then okay, if these competitors are solving this, and actually you can go even further, like you can go to a question and see which teams have solved it. So if these are like teams, like friendly teams, then you can say, this person knows this stuff, so if he solved this, then this must be a question on that. So it can work, but for me personally, in the past team and well as in ours, whenever we did that, we got it wrong. So there were a few questions that most of the world has solved, but we couldn't solve. So if we had tried to optimize this question, a lot of people have solved, and if we had tried it continuously, we would have failed. But there were also questions where almost none of the other competitors in the world have solved, but we solved it in a few minutes. So I'm not saying that we are like great or anything. It's just that the difference in experience. Like all of us, all three, are electrical and electronic engineers. We are not computer science students. So we have a different experience behind us. So the things that you find easy might not be the things that others find easy. So, and also even if it is a friends team, you there are things that they might have learned that you don't know about. So even though say this person doesn't know this, they might know that. So for me personally, I think that trying to hack the leaderboard to pave your way hasn't worked for us. So since like the E21s as well, you can try it out in other like less competitive, like not like big thing like IEEE Extreme in other competitive coding competition. See for yourself whether it works for you or not. There's an argument for both ways, but for all three of us, it hasn't worked out. So that's one thing that we would like to mention.
Yeah,
So
that's
any
true.
other stories, Sathar?
So now to expand on that topic, Praveen mentioned that if someone solved a certain problem, it does not imply that we should try to do it and we should be able to do that. In the last IEEE Extreme, we got a problem called cosinus. I think all the teams who competed in IEEE Extreme 17.0 cannot forget that, because that question was wrong. And it was a mathematics question. And it is pretty obvious that it is always directed towards me. And it was not very hard. It had a certain edge case where we should think a bit, but the initial implementation was not that hard. So it was just solving a linear definite equation using extended Euclidean. It's very obvious answer. And Praveen and myself discussed about that answer and we implemented it. And before we consider that difficult edge case, luckily, we used an assert statement to make sure that we are doing all right. Then we noticed that something that we did not expect is happening, because let's say, for test cases where that edge case does not exist, still it gives runtime errors. And we were stuck in that problem for a long, and we had in that policy where we don't look at the leaderboard, but I looked at it to make sure that I'm not attempting an unsolvable question. But some teams have solved that now. I know
Actually,
that
considerable number had solved it, or rather, they had gained some marks.
yeah, we didn't know how they solved it, so we tried it for about 12 hours. So
Too much time.
more than 8 hours. We did not look at that question for the entire time. We say I am doing another question
Off
and I'm
and on
done.
again.
We come back. Yeah. So now I said that we were 69th initially and we were 65th when the official rankings were released. And I think the reason behind that we increased in ranking has much to do with that question, because there were some teams that were leading when it compares to our team had solved that problem. So
to explain more, like that question was removed.
Yeah,
so even the time that is spent on would have been completely useful. That even the marks will be removed. So like those things can happen. So like this is why we say like trying to like do too much like reverse psychology stuff usually doesn't work for us, at least.
And now in competitive programming, when you are doing competitions, knowing about coding is not enough. You should have the common sense, especially when the question states that you should consider all the vowels. You should know what the vowels are. I think Buddhi is here. Buddhi,
yeah, so I'd like to comment on that.
You can comment on that about vowels.
Maybe I should mention the question. So the question was, I think, find how many vowels in that word. So like somewhat like that, right? So
It's one of the easy questions.
Yeah, I have done is I have put every vowels into an array, but I have missed one vowel. So
this one vowel means now the story. You should tell the story. You should tell the full story. Now. Buddhi tried to solve the problem. So, and he was very confident about his solution, but it gave all wrong answers.
No, actually, the answers we got some points.
20 or something. Yeah. 20 out of 100. That is not sufficient because he was so confident, because it was an easy question and Buddhi is the expert when it comes to strings. Then he was very frustrated and gave it to Praveen. And Praveen asked from Buddhi the approach he took, and Praveen coded the exact thing. Praveen did the exact same thing, but he implemented it from the scratch, and he got all correct. And then Buddhi,
here comes the interesting part. And when I'm looking at the Praveen's code, I see like his array is somewhat long than mine.
Longer than Buddhi's. So that's how we realized that Buddhi does not know what are the vowels. So what is the vowel you missed? Is it you?
I or something.
Yes. So within I as a
Okay.
vowel is something to consider about.
Another thing, like this is not like a personal thing, that this is somewhat true in general, like discussing questions. Like you should talk about stuff when you are when you're doing competition. So like we most of the time did competitions at my boarding place, so we would shout at each other like do that, or that won't work. Uh, so you need to try this and stuff. So and also like know your strengths. So a very common thing is that I like write an algorithm, but I usually get things like you need to add one to it and stuff like that wrong. So then I hand it over to Athulya, and because he is good at those stuff, very far thinking about the very fine points, like where should you actually do this stuff. I can give a high level point, but I'm very bad at doing the low, like some of the finer details of the thing. But he's very good at it. So I usually give it to him. And also he's very good at coming up with test cases which can break a solution. So if we can't, like Buddhi and me both, if we can't really find why our solution is not working, we ask Atulya to be our test case generator, and he generates test cases and give it to us. And then usually actually the part of the story that I didn't mention about hospital queue was it worked for some part of the test cases, but a lot of things I didn't get it right. So he read the question and developed some test cases, and it turns out that I had missed part of the question that deal with like greater than or equal type thing, which I'm very bad at. So and I couldn't really figure out how to integrate it into my solution either, because I'm usually bad at that stuff. So I gave it to him and he told, oh, okay, this should be the logic, and I implemented it and he gave us a full mark. So yeah, like again, like also like if we want like part of our solution to be like written by AI or something like that, we don't use it that often, and AI can't really give you a full solution for these type of questions, but you can use it to generate part of the algorithm. So it doesn't never works for me. Like if I try to prompt AI to write a solution, it almost always gives garbage. But Buddhi is very good at it. Not just prompting AI, he's very good at like writing solutions as well. But he's also very good at that niche thing. So
Prompting
usually,
thing.
if you want to do that, Buddhi is the man. Uh, and
And
also he's very good at like using online references to find like what should be the best algorithm.
and
Another reason,
solve the questions that you have tried earlier.
yeah, he remembers everything. I remember nothing. So yeah, it's like that. I might solve a question yesterday and won't remember it today. I will resolve it again. So uh, like, and the other thing is like why you should talk about is like, even if you don't really know about it, if you think like so another story, there was a question that we had in our last IEEE. So and I didn't really have an idea. I was attempting it. I didn't really have an idea, so I just released it. Okay, this is a question like this. uh, and so do you guys have any idea? So Buddhi had been looking at lazy propagation in segmented trees. So he mentioned, would that be useful? And I said, okay, maybe that would be useful. And I went to the bathroom. Okay. And Buddhi had recognized correctly that the lazy propagation part was needed. And he was actually
Actually,
solving.
I was just mentioning that.
Okay.
Not even.
He was just mentioning that apparently. But the thing is, when he said lazy propagation, I was actually working on an algorithm. I realized that the basic concept, or the idea of lazy propagation can be implemented into that to make the algorithm work for the problem. So we did that and we got full marks. So again, like another reason why you should talk. Like even if you don't think the idea is like maybe relevant, just say it out loud because it might imply another solution. And actually, it was
You should discuss and you should take rest. Going washroom means, in other words, he took a rest He took it, he set out from the computer programming environment. That's how he realized that this can be used. So taking rests is
So
also
another thing with rest is like we also went to like a shop and got us like drinks and bites to eat. Actually, me and Athulya went, but this trade got it. So
and when we came back, Buddhi has completed about 3 questions, I guess. He has got correct
yes,
of one that we were struggling with.
so like that. So you need to take rest. One thing we didn't do that we maybe should have done, we don't know. Like we didn't really sleep much in during, like we didn't take sleep breaks. So at the end of the competition, we were almost zombies and we couldn't really do anything.
But I did sleep. And
Yes, he
Buddhi is
did sleep.
making fun
He
of me
did
about
sleep. We didn't do anything. He slept. So,
not for a long, about 5 to 10 minutes. And Praveen always disturbs me. He did not let me sleep.
yes, I kept giving him problems to like debug and find test cases. So
Yeah.
yeah, there are
And,
stories like that. Okay,
another interesting case that when it comes to taking rests were in Coders 9.0, we had a problem to find the minimum distance in a surface of a cone, right? If I remember correctly.
yeah,
So Praveen came up with an interesting solution, and we implemented that, and I checked that, but we could not find any fault in that. But still, we got every test cases wrong, and we were very frustrated about that. And organizing committee insisted us to take the dinner because the food will not be good to eat after 9 p.m. So they mentioned like
we
that.
resisted a lot.
Yeah,
We
so
wanted to stay and compete, but at their insistence, we went.
we went. So while we were eating our dinner, Praveen just again used his physical strength, I guess, and he had the idea that he got the point that we have missed, and that was the end of our dinner.
Yep. I ate as far as we could, and we went back to the competing environment, and we finished the competition. Like maybe one final story about like different viewpoints of the same thing.
Yeah. So you're talking about the Dora lens multiplication thing.
Yeah. Okay, that's another story. You can just say that. I'm actually going for a different one, but
I
you can
think
go.
I will
I'm
give
talking about Heshan's crush.
Heshan's crush. Well,
Because
we will talk
at
about
that
those two
competition,
stories.
Buddhi was in a different team and they had solved it in a complete different time. So you can say that Dora plus multiplication first.
Now, the Dora lens multiplication is a very easy question. What we had to do was to multiply 2 numbers. That's it. They give us 2 numbers. We just need to multiply it. So the problem was the length of the number, the digits of the number was like the number had like million digits. So we had to multiply 2 numbers, each having million digits. So now in computer programming, we know there is some irritating guy that we encounter the most called time limit exceeded. It means that our code is not optimized enough. So we need to optimize it. So we were trying it, but then suddenly we thought about now we are talking about fast Fourier transforms. Don't worry if you don't know fast Fourier transforms. Yeah, please do worry and go and learn. So we use fast Fourier transform for polynomial multiplication. So then we thought that why don't we use this algorithm to multiply 2 numbers? Since we
Actually,
know from
Athulya came up with that idea.
yeah, it was a teamwork actually.
Yeah.
So now we know from linear algebra that numbers and polynomials has something to do in common because both of them are rings. I think E21s are aware of them about rings. So the algebraic structure where the polynomials and the full numbers are in is rings. So this should have the same structure when it comes to algebra. So multiplication is an algebraic thing. So why don't we use fast Fourier transform? So it came from nowhere because we did not use it to multiply numbers before. So we had to do some modifications we had to have a carrier since we have a limitation to the digit that we can have. So when
So actually, we
we
later learned that it is a common thing to do with F50. So F50 is commonly used, especially for large number multiplications.
Yeah.
But at that time, we didn't know.
You did not know
Figured it
that.
out at the time.
No, considering the fact that we are electrical and electronic engineering students, we used F50 for signal processing, not for numbers, for number arrays. So we know that the coefficients of a polynomial can be represented as a number array. So we use, we know that polynomial multiplication is a convolution. So we can use F50. That's what we knew. Then we came up with that idea. Then after the completion, we realized that this is a very common approach. So thinking differently, thinking out of the box would help you a lot to beat the other teams, because they would not think in the same way that you are thinking. So that's the story about Doralon's multiplication. And as the final story, we would talk about Hesham's question. We will present.
I want to
When-
add
Ah,
something
okay.
as well. So when the question when your solution ran out of time, I mean the time exceeded comes, you try changing your languages. Actually, the
yeah.
GPTs can do that uh, actually pretty good. So try change the languages to C++ or C or something, that sometimes it works. That we had some chances like that as well.
And Buddhi did the translation part.
Yeah,
And before
actually,
changing the
not me.
language,
ChatGPT.
Buddhi is the expert of using multiple languages when it comes to competitive programming. He somehow do programming with the languages that he hasn't really programmed in his entire life. We don't know that how he does that, but he does it. And he gets good results. And one thing to mention, before changing languages, try changing interpreter. Now in Python, Python 3, and you have an interpreter called PyPy3. In some cases, depending on the problem setter, some problem setters give less time to Python 3, and they always forgot to reduce the time for PyPy3. There can be certain things in IEEE we can't expect that kind of things happen, but it is worth a try, because what you have to do is you just change the interpreter and submit the same code again. Sometimes it works.
So we'll go with I mentioned the Hesham's class last, and I would like to tell a story on you'll never be ready, but you should attempt it anyway. So we'll get to that later. Anyway, the Hesham's class was that we had a question, and like me and Athulya was we were on one team. Buddhi was in another team. So like the way we solved was using average velocities. There's some fun stories there as well, because we didn't realize average velocities can be used. I just asked him to find out the expression for average velocities, and we realized that some of the constants just dropped, and we realized that okay, now we can use that to solve the problem. I don't know, what did you use for that, Buddhi? Did you use the like?
Actually, we did some physics one, and actually one line code to get the answer.
Yeah, it's a one-line code. Like I think all of us came up with the same expression. But my point
And
is that
other thing is, when we were looking at the question, that was described in a YouTube video as well.
okay,
So
so they
we just
found
got-
the online reference as well. So anyway, where that's another way. We found it in a different way, and I think believe a friend of ours called Timira did it using VT graphs. So things you do in applied mathematics and also in your physics. So he used that information. So you can use different information for different domains. So the thing is, like, I would like the people here to pass on the message to others in the batch. Just try it, because maybe you'll win, maybe you won't. But I guarantee you that the people who don't like programming at this point might actually start enjoying it afterwards. There's a story on that. We'll get to that later. But the point is, like, as I said before, like the problem with our like participating in Sri Lanka and as well as in our university is that there's not enough teams participating. But the teams who participate score very well, but there are not enough teams participating. So I encourage you guys to like spread the word, because like participating or IEEE Extreme, it does cost a bit, but later on you need the IEEE membership anyway for different for participating in other competitions and stuff. So I encourage you to participate in this competition and other competitions because for the benefits Athulya said, and also it's like don't forget that it's really fun. Like we enjoyed like the 24-hour competition a lot. Like we had fun, we joked, and like it's quite fun.
That
And
it came because we did not check the leaderboard. Now you
yes, yeah,
can't see the
that's the
rank.
thing.
You can't unsee the rank because it is always there in the top right corner, I guess. So it's just ignore that.
You have to ignore that. So you will
Some
really enjoy it if you don't think about it. You're like you take it easy. You enjoy yourself. Just have fun with the questions. That usually is the best approach. And as for competing, like I would like if like most of the 21st batch and the 20th batch and the 19th batch competed, because this time around actually you guys have more, even if you don't know, have less experience than us, you guys have more of a chance at competing, because like we are in now we are doing industrial learning, and then we have a final years stuff, and we have to think about like other stuff, future academics and stuff, things like that, because we may have less time to prepare than you guys. So you guys may have more freedom and more time to prepare for this competition. So you guys actually have a better shot than us if you really put your mind to it and like really try your best. So at least you'll learn something. So do we tell the story why you should try even if you're not ready, Atul?
yeah, I
Okay,
think
so a
it's better.
certain person was on the of the opinion that he hated programming, and we insisted that he should participate in a competitive programming competition, and after that competition, he's on the mindset that like coding and maths are the best things. All other things are horrible. So like that thing, competitive coding, and participating in that competition dramatically changed that person's outlook on programming. So those things can happen, and he was of the opinion that he was not ready. Like he didn't know anything about algorithms, but we consider that like his math ability will be able to help us. So he agreed, and now he knows a lot about algorithms and also mathematical algorithms. And so he actually was a help at that time, but he got motivated and learned a lot later as well. So that thing can happen. So I please send the message to others to participate, because like even if they don't have to try, they don't have to study or anything, just participate. Like even if you enter and don't do anything, it's fine. Like you can actually at least have your name on the leaderboard if you at least try a few questions. And like as there are a few easy questions that you can try anyway, like finding the number of vowels. That is a fairly easy question. Although, but the Mr. Vowel. So if you don't do that, you will get full marks. So that is it for us, I think.
Yeah. So that's it from our side. So yeah.
Thank you very much, Mr. Athulya Ratnayake, Praveen Sumanasekara, and Buddhi Wijenayake for sharing insights and experiences with us today. Sure, we all can agree that it was really inspiring and really fun as well, entertaining as well, with all the personal stories and experiences that they shared. So now we have a deep understanding on what IEEE Extreme is and how we can prepare for it. So now we will start our Q&A session. So if any of the participants have any questions, feel free to ask them by unmuting your microphone, or you can drop a text in the chat box so I can read it out to the presenters and they can come up with the answer that you're looking for. So are there any questions?
Look, I guess there was some question directed to Praveen earlier. So the question was about whether it is able to, whether we are allowed to have a team member from a different university. I don't think that it is allowed because now if you go to the leaderboards and see, there is a thing called the university ranking. So you should be from a single university, I guess. And in the rules, they mentioned that something that okay, I'll read it. This says that well, I can't find it now. What it was about.
Athulya, you can link, send the link for the rules and regulations if you want, so they can.
There is. I'll send the link to the page eligibility.
Okay.
That is where this exists. I will put it into the chat to make sure that it is not directed to Praveen. Well, now this is the page for eligibility, and you can get an idea about the eligibility stuff there. And to answer that question, I don't think that you can have a team member from a different university because they rank the teams with respect to the university as well.
Although you can do your own research and find out, like we haven't like done a deep research into that, whether that is possible, whether there are special circumstances that you can do that with. So if you are interested in that, you can do your own research. So we don't think it is possible, but maybe there are special ways that you can do that. So like you can feel free to do your research.
Okay, if you have any other questions, please do ask.
Yes. Anyone has a question? Yes, there is a question. So the question is there a method to turn the algorithm idea in our head to a coding language except using ChatGPT and stuff?
Ben is the best person to answer the
Yeah,
question.
Buddhi.
Buddhi.
Yeah,
Yeah.
best question.
I think that's Buddhi's question. So
No, I mean, I have only tried it ChatGPT and the Bard AI, I think. So what I have done is I give the question, and first I get an explanation, and I get the, if I can't implement on that summary, I try to get the code as well, and I run the code. If that fails the uh, the question, I try to implement by my own. So the thing is, sometimes ChatGPT can answer some of the question, some of the parts in the question. So the parts that the ChatGPT can miss can be implemented by us. So that would be easier for us actually when it comes to a big problem. The half of the problem is done by ChatGPT and the other half is only to done by us. That would be easier and it will save some time as well.
So you need to collaborate with the generative AI,
Yeah.
not only the generative AI. If you can do it by your own, that's good. But now we have since we have the resources, we have to use them because there are no restrictions.
Yeah, to like expand on that, the question actually somewhat intrigues me when they say like, is there a way to turn the algorithm in your head into a code without using like generative AI tools? So like the other way is to code it yourself. Like actually the one of the easiest way to explain an algorithm is to code it yourself. If you're using libraries and stuff, you can almost like write the code in like languages like Python, like you are explaining it. So it's not that hard if you actually have the uh, algorithm idea in your head. So if you can't actually do that or explain it to an AI, maybe there are like blind spots in your algorithm. So when you actually like this is an experience of mine, like when you think about an algorithm in your head, okay, you think oh that works, but sometimes when you try to only when you try to implement it, that you realize that certain thing is more difficult than you think. So for example, like inserting a element into a random position in an array, and like you may think that like dot insert or something like that can work, but like you need specialized data structures in order to do that. So like something that can be easily explained in English in an algorithm, like if you are like easily explained in English, might not be able to be efficiently implemented in an algorithm. So that's something also you have to consider when like doing that.
Thank you very much. So the person who asked the question too has dropped a message saying thank you very much. He has got the answer that he was looking for. So any other questions from the participant? It seems that that was all the questions that the participants had. So thank you very much again, Mr. Athulya Ratnayake, Praveen Sumanasekara, and Buddhi Wijenayake for sharing your experiences and thoughts and teaching us on how we can participate and all the benefits that come with participating and winning, of course. And for the participants, I encourage you to convey this valuable message that you learned here to every one of your friends who are interested, who aren't interested, and show them how advantageous participating in IEEE Extreme this year and then in the next years to come can be. So again, thank you very much everyone for joining, and okay, we will end our session now.